All right, we'll go through this paper. That is the engineering mathematics. So this mathematics, which is MA210, covers industrial, pure chemist, and just education chemist. So these are the classes that are getting this course. All right. So others, they are not taking. So, but for practice sake, you can be going through. Okay. So without even wasting our time, shall we start? So be very fast. Okay. So these are the questions such that. So the question that we are given is to show that or verify that this one is equals to sec. Okay. So what we are going to do is we know sine theta, all right? Then sec theta. Okay. So I need to write sec there. Okay. So we have 1 over, okay? So I can say 1 over sec, okay? This is equal to cos, okay? Then 1 over cosec, this is equal to sine. Okay, so now we have sec there here. All right, so I'll put 1 over okay, so they are vice versa. All right, so meaning that even x, even cos can also be given here. I mean, even sec can also be given as 1 over cos. So I'll just substitute there 1 over cos theta. Okay, so this is the sine theta over cos theta. And we know sine theta over cos theta, that will be tan what? Theta. So we have shown this one. So that's how you are supposed to do such simple equations or operations. Okay, so what about the second one? The second one we're told to show as this one is equals to that. So what we need to do here is we have difference of 2 square there, all right? 1 minus sine. Okay, so I'll be very fast in answering this paper. I'm feeling tired. Okay, let me do it from this side. So I'll be very fast in answering this paper. So what I'm going to do here is I'll say I need to find the common denominator there. All right, so I have 1 minus sine x, all right, then plus 1 over 1 plus sine x. Okay, so what is common there is 1 minus sine x over 1 minus plus sine x, like that. Okay, so now these now are multiplying, so this will be just 1 plus sine x. Again, again 1 minus sine x. Okay, so from there on top there you can see 1 and 1, they are making 2. All right, but this and this is minus, so it will remain like that. Then here down here is the difference of 2 square, so I'll just get on the negative part and square this on the negative part. So I'll say 1 minus sine squared. Okay, so this will be from this basic identity we know cos squared plus sine squared x is equals to 1. So now it's more like this one has gone there, which is giving us cos squared is equals to 1 minus sine squared x. So this is the thing that we are supposed to write, right? So that is what we are supposed to write, meaning that we have cos squared there down, so it will be 2 over cos squared x. So we said cos is same as sec. All right, so this will be just the 2 1 over cos squared. Now it will be also sec squared, just like for the first case. Okay, so we have shown that one. So that is it. That's how you are supposed to solve these questions. Okay, so some questions I'll be very fast, such that I need to be with time. Okay, so you just have to keep practicing. Especially one thing that I can tell you for MA2, this MA210 of yours, you need to do more of the. In fact, I have even the tutorial sheet recorded video as well there, whereby he's getting questions papers, so you can just inbox me if you want. So the line is, you know my line, all of you. So the thing is, here we have cos. Okay, so there's for sine and cos. In fact, there are two. So we'll show how they are used. So if you have sine, okay, in this case, I have whatever here they will put, then minus theta. Okay, so for sine, it goes like you write sine this one, then cos this one. All right, so here it will be sine, which is just them say 90 because pi is 180. So that is 90. Then you say cos, okay, theta. So here it will be now you maintain the sign like that. Okay. Then for sine, we don't change the sign here. For cos, the sign will change. So what do we do now? It is now the same cos. This cos now they are changing the sign. So this will be cos 90, then sine theta. Okay. So how do we do this? This is 1, right? This is just cos theta, then minus cos 90 is what is 0. So this is just cos theta. Okay, so we have shown this one. So coming to this one now, this is now the case of cos. So for cos, it goes like whatever they give you inside there, this will be given by, so cos x minus 45. This can be any other angles. Okay, so how do we achieve this? You say cos this one, okay, cos x, all right, again cos 45. Okay, then minus, for cos now it changes to plus. That's what we do. So now it will be sine x sine 45 degrees. So now from there, then what we are going to do here is we'll say this is now cos 45 is, I'll even write like that, is 2 root 2 over 2. That is cos 45, and sine 45, that's the value. So I'll write cos x, okay? Then plus, again here I said same as cos. So this is the root 2 over 2. That is sine theta. Meaning that this will be now, I can just factorize the same thing. Since it is common, we have cos theta, then plus, in fact, it's cos cx. All right, they are all x, but allow me to write as theta or any. Let me just write the same x. Then this will be sine x as well. So this is what we are supposed to do, and you have shown. So let's go to the next question. So for this one now, we are saying find the what? Find the limit. Okay, for the first one, find the limit if they exist. So here for a polynomial, limit always exists. Okay, so what we do for a polynomial, just substitute. Okay, first step, I'll just substitute. So I can write to say lim, okay, as x approaches 4, then open bracket x to the power 3, then minus 4 x to the power 2 plus 5 to the power x minus 8, like that. So you substitute the value of x. So that will be just 4 to the power 3, then minus, for polynomial case, okay, you don't have to conjugalize and also find the denominator, everything like that. No, for here it's just straight. So put 4 there squared, then plus 5, 4 minus 8. So you leave lim after you substitute the value of x. So from there, we'll say 4 times 4, that is 64, right? So that is 64. Then minus, that is again here 16. 16 times that, that is 64 again. Then here is 20, right? Minus 8, which will give us, this is 0. That will be now 12. So that's how we are supposed to solve that one. Then for this one, it is quite tricky. It is quite tricky, this one, because it needs one of the identity. Okay, and the identity that they want is different of 2 square. So they are just testing us how we can interchange these arrangements. Okay, so that's what they wanted. So now we can say for B, okay, so we have lim as x approaches 1, okay, then we have x squared minus 1 over x x minus 1. So this is difference of 2 square, right? It can be written as x squared minus 1 squared, okay, which is over minus 1 like that. So we say lim as x approaches 1. Okay, so the next stage that I would do here is I will do this identity to say this is x minus 1, open bracket, again x plus 1. That's the meaning. Then I have x minus 1. Okay, so I'll say lim as x approaches 1, lim is given by this. So we substitute now. So I'm substituting that first. Before that, we can see that this and this can go. So say x plus 1. Okay, lim as x approaches 1. So you just substitute there where there is x now at this point. So it will be 1 plus 1, which is 2. Okay, hope that was clear. So let's go now and solve this one. So this one is saying we have, so it's an identity. So we have, when you have x cubed plus 1, okay, you say x, so this is giving us x minus plus 1, then you maintain the same x plus 1 the way the way it is as the initial. Okay, so what you do is you say, for this case, for this identity, you say x, okay, then plus 1, you cross like that, then you open a quadratic. Now you say x squared, okay, now here it will be minus when it was positively. So here it will be, now it will be like x squared. This is a quadratic, like find the quadratic of this. So that will be just should be 2x if I'm not mistaken, or x, it should be x, yeah, if I'm not mistaken. So then plus 1 like that. Okay, so let us prove if it is the same thing. We can prove that. Okay, it can be 2. So if you put 2 there, let me do this. Okay, so that's the identity. So what you are going to do here, if it is negative now, okay, so this is an identity, then you say this, you follow this negative here, then open bracket x squared, then here it will be plus, okay, x plus 1 like that. Okay, so that's how you are supposed to write these two things. Okay, so that's how you're supposed to write these two things. Okay, so that's the identity that you're going to use then. So now we'll go and substitute here and we'll see what will come out. All right, so now coming to this one, so say lim as x approaches 1, okay, then we have, meaning that we are selecting this one, so we have x minus 1, then x squared plus x plus 1. Okay, then over we have x minus 1. Okay, then this and this goes. Then now the next stage, now I want to bring this word lim. I'll just substitute now in this one that I've remained with. So I'm substituting, that will be 1 plus 1 to say plus 1 again, which will give us 3. Okay, so that is it. I don't know if it's supposed to be, but this is the identity if I'm not mistaken here. Should be, if it is not 2x, then it is like this. So that's how you're supposed to solve that one. So it requires a lot of time. Just that I'm explaining, I would have solved it very fast. Now I want to leave some knowledge with you, not only solving as if it's a revision, but I want also to teach. Okay, that's the reason why I'm very slow, and you need to make sure that when you learn this, you forget that you need to start them. So okay, then for this one we have rim, okay, as x approaches 4. All right, root of x minus 2 over 4 minus x like that. So what do we do next then? All right, So what do we do next then? We are going, the target is now, we don't want to have 2 down there. I mean to have 0, because if we substitute there, it will be 0 and it will be undefined. Our expression will be undefined. So this, I'll say x is equals to 4. All right. So now I'm going to find the conjugate of this one. Okay. That will be now x plus 2 over the same thing, which is x plus 2. Okay. So then from there, I multiply now. This time this is x just. Okay. Then this time that is plus 2 root x. Okay. Then again, this time that is minus root 2x, like that. Okay. Then this time that is negative 4. Then we have this time that will be 4. Okay. Minus x. Then open bracket root x plus 2. Okay. So we can see that this and this is going. So we'll say lim x, as x approaches 4, then this plus that will be just x minus 4 over 4 minus x, open bracket, root x plus 2. You see, I can't cancel here because the way they are. So I'll multiply this one by a negative so that I can maintain there. Throughout by negative. So I'll say lim as x approaches 0, I mean x approaches 4, then that will be, I want to divide throughout by a negative. So I'll say x minus 4, all right? Then here, I'll say a negative there, okay? So inside, meaning that I can have negative 4 now, then plus x. So that if I multiply this negative, I'll still go back to that. That's the reason why I've done that. Okay, so meaning that this one now, I can just rearrange inside there, okay? So I'll say lim as x approaches 4, all right? Then that will be now x, okay, minus 4. Then still have negative, then open bracket. I'll say now x minus 4. They have just rearranged this one, then this one comes there. Then I have root 2 plus 2. Okay, I mean root x plus 2. So you can see that this and this now are going, will just remain with a negative. Negative. By the way, once you substitute now, when you haven't substituted, I'll say on top there I'll remain with 1. Then the negative is here. Then I'll remain with root x plus 2. If you now we substitute now, at this point, we'll remove the word lim. Okay, so we'll remove the word lim and we'll put 4 there. So that will be 1 over root 4 plus 2, which is negative 1 over root 4 is 2 plus 2, that will be 4. Right? So you end there. So that's what you are supposed to do. I don't know if I have disturbed the format, but this is how you are supposed to do. So that's about this one. We are done with everything here. Just imagine 20 marks. Okay, let's go to the next thing. So this one is telling us to say differentiate from first principle. So what we need to know is that the first principle will be given as, okay, lim, okay, lim as h approaches 0 of f of function, that function you'll be having, all right, that function you'll be having plus h minus the same function we have, then over h. So that's what we'll be doing. So lim as h approaches 0, then the function is what? Cos x. So we'll say cos, open bracket, we have x plus h, okay, then minus the same cos x, okay, over h, like that. So say lim as h approaches 0, then this way, remember this identity composite function. So what we do here for cos, it will be cos x, cos h, then it was plus here, so it will be minus, right? That's what cos behaves. So here it will be minus, again sine x sine h, okay, then minus cos all right, x, then over h like that. Okay, so that's what we'll be doing. So now we can see that now um rim rim lim as h approaches 0. All right. So now what I'm going to do here, I'll factor out what is common. Cos x is common. So cos x, it will be cos, all right. By the way, I need to group the right terms here. Okay, let me just group the right terms. So here it is giving me cos x cos h minus cos x minus sin x sin h over h. So this h is for everything, by the way. So what I'm going to do is I can say here I can factor out between these two. So I can say that is cos. By the way, I don't have to leave that word lim. So I'll write from here. So I'll say lim as h approaches 0. So here we have cos. Okay. So cos and cos there. Cos x is common. So I'll remain with cos minus 1 there. Okay, when you factor out this one, then minus, okay, minus the same sign now. I'll say sign, okay, I'll say sign like this, then sign over h. Let me just distribute this h. So we need to know that lim as h approaches 0, then this one, this identity cos minus 1 over h, or in short cos x minus 1 over x, this should be 0. So that will be cos x, then open bracket 0, minus, then this here it will be what? Then again we need to know that sin x, okay, then since we have h there, dot sin h over h. This, I've just removed this one into this one. It's still the same. Okay. So this will be 1. Sin x over x is 1. So here, meaning that this is 0, right? So meaning that the answer will be just negative sin x. So that's how you are supposed to answer this question. Okay. So what about the second one now? Okay. So how do we answer the second one? It is also the same. Provided we know the formula, there is nothing which will be difficult. So we say as h approaches 0, so f of the function, okay, minus, okay, this is plus h, then minus f of x. So this is the formula, then over h. So this is what we'll be using. Then lim as h approaches 0. This is first principle, by the way. So now what I'm going to do here is 1, right, over, we have x plus, whenever there's x, that's where you're putting this, then minus the same function is what? The same function is 1 over x. Okay, then the same function is now being divided by h. Okay, so now this will be lim as h approaches 0. Okay, then here what is common? I'll find the common denominator. So I have x there, open bracket, x plus h. Okay, meaning that here it will be just x plus h, then minus, no, it is not supposed to be like this. I've swapped. Okay, we are crossing multiply. So the common denominator is x. So we'll start with this and then minus that. So it's 1. This time that is c x. Then minus this one. This negative 1 times negative x inside, that will be negative x. Again, the same negative 1 times that, that will be negative h. Okay, so lim as h approaches 0, then this goes, right? We have negative h over x, open bracket, x plus h. Okay, remember at this point we are still dividing. Now dividing this, it will be the same as 1 over h. It will go down. it has 1, then the 1 will come on top. So meaning that we have h there, multiplying this guy. So meaning this and this will go, and that will give us negative. By the way, I will still write lim as h approaches 0, then that will be negative 1 over x open bracket, then x plus h. So now substituting the value of x, so h, so that will be x open bracket x plus 0. H, as h approaches 0, that's what they were saying. So now that will be now just x inside x times that will be negative 1 over x squared. Okay, so the answer is negative 1 over x squared. So that's how we are supposed to solve this one. So that's the answer. Okay, we have just remained with these two questions and we'll be done. Yourself. So now the thing is, we'll solve question. Okay, we are solving this one quite long. So when you see such form, you differentiate this one. How can you differentiate this one? There's no rule that you can use. This is a fraction, so we use what we call product rule. Okay, so I mean not product quotient, yes, because we have something there which can be u, then we have v there. So to differentiate this function, we'll say this is a quotient rule, of which it will be given by the formula. Differentiate what is on top and maintain the denominator. So we'll maintain the denominator, then differentiate what is in the top. So I'll choose this one to be u on the top. Then minus, again now you maintain u the numerator, then you differentiate the denominator. Okay, then over u square the denominator. So now individually I'll say my v is we know our v is that is sin x minus 2x. This is our v, which is the denominator. All right, then I'll just find let me start with u prime. Okay, so u prime is what? U prime, I want to differentiate what is on top there. So differentiate what is sin x, divide dx of sin x is what? So what you do is, for this case, you do this. You say in the y we find the sine. Okay, then here cos. Okay, so when you differentiate clockwise. Okay, when you differentiate clockwise, is it clockwise or anti-clockwise? Okay, it's clockwise. So when you differentiate clockwise, when you're going like this is clockwise. Like this is anti-clockwise, right? So meaning like this, you're differentiating, like this, you're integrating. So if I have for you on top there sine x here, meaning that you give us cos x. So differentiating this one, that will give us cos x. Then cos x, it's giving us negative sine x, because sine is negative there. Sine x. Then coming to v now, we also need to find v prime. V prime will be given by, you differentiate what is down there. So in sine x, it's giving cos x, right? Then, by the way, this is minus. Then again, cos x is giving what? No, we're from differentiating sine x. So I can put a negative there. Then what is the cos x is giving negative? So that will be just positive cos x. So now substituting in the formula, y is equal to, substituting in the formula now, so we have our v now is, so allow me, the space won't be enough. Let me write here. Master this thing I'm labbing here. So substituting in the formula, so we'll have u is now the down part. So I'll say sine x minus cos x. Okay, so this is my u. Then my u prime now is what? That was my v. My u prime is cos x minus sine x. Okay, then I have this minus there, open bracket. So now meaning that I'm putting now u, I'm maintaining u. So u is what is on top. So I'll say sine x plus cos x. Then multiplying now with the v prime. V prime is here, cos x plus cos x, right? All right, so let me see you. V, the way we differentiated, no. V, no. V here is giving cos. So I've really made a mistake. I can't get cos situations. Everything cos, no. It should be, one should be sine. So differentiating this, what is done here, okay? Let me differentiate it properly. The u, how do you differentiate the u? So differentiate u as this one sine, it will give us from that graph I drew, okay? That will give us sine positive. This is cos positive. This is cos negative. This is sine negative. So meaning that I have now, I'm differentiating everything. It's not product or anything else, no. So now I'm differentiating this one. So differentiating this one now, which is now sine will go into cos, okay? Then negative cos, it will be negative cos, it will be positive sine, right? So that will be just a positive sine x. So I'll put there cos x plus sine x. All right, so multiplying now will be, this is prime by the way. Multiplying this sine times sine, it is sine x, okay? Then cos x, okay? Then again, I have this sine x times that will be negative sine squared x. Then again, x sine is done with sine. We are done with sine. Okay, we multiply this time that and the same sign time that, okay? So now it's cos. Cos time that is negative cos squared x. Then again, that time that will be plus, okay, sine x cos x. So I'm done there. So I'll come here, okay? Then this time that will be sine x cos x. Then again, this time that will be plus sine squared x. Then this time that will be plus cos squared x. Again, this time that cos times sine, that will be sine cos. Okay, that is cos times that. Okay. So now what you're going to do is we'll say sine x cos x minus sine squared x minus cos squared plus sine x cos x. Remember the denominator here, this is squared. I'll put it later because it will disturb me in the space that I have. Remember at the end, that's when I'll put it. So this is sine x cos x minus sine squared x plus cos squared x. Then plus, no, it's minus again. That will be minus sine x cos x. Remember there's a denominator of which I don't want to show it. So I can see things, this sign here, okay, this cos here, all right, this cos is squared here, it is cos is squared by the way. So this cos is squared will go with this cos is squared. Have you seen the way I'm cancelling? All right, so this sine x cos x and sine x cos x will go, right? Then I have again sine x cos x, again sine x cos x. So this and this again will go, you see? So I'm remaining with this and this. Okay, so I'm remaining with y is equal to negative sine minus negative sine squared. So I have negative 2 sine squared x. Okay, so now that I have this, now I just need to square the denominator. So I can't even sometimes square, I'll just leave it to say because I can square it, but I'll just leave it. You can square if you want, but you are going to expand it. Okay, so that's our v. So this is what you are supposed to write. So that's how you are supposed to do this. It wasn't really a big challenge. This was very simple. Even you yourself, you can relate that it was very simple. Okay, so the thing that now we'll do is we'll differentiate natural log of this thing here. Okay. Okay, so what I'm going to do here is I'll say I'm differentiating this one, by the way. Y is equal to x to the power 3, then natural log of x. So this is product rule, right? So you say y prime is equal to, or dy dx as same as y prime. Then what I'm going to do here is I'll differentiate this one, then I maintain this one. Next, I'll differentiate the, so suppose this is my u, this is my v. So I'll say u v prime or dv, then plus again v du. You get? So that is what I'll be doing. There are two things. So this is product rule. So I can choose to say I'll differentiate this one here at this point. So doesn't matter the order. So you differentiate this one, that will be, when you differentiate 3 to the power, that will 3 will come there, that will be just 3x, okay, the power 2. Then I've differentiated the meaning that I'm maintaining what? Natural log plus, okay. Then now if I've maintained natural log, now I'm differentiating natural log. So natural log of x is just 1 over x. So this is 1 over x. If you differentiate, then times, so that is the du now, times the v, which is now natural, no, not natural log, which is x cubed. You differentiate the other one, you leave the other one. So that will be now x. So I'm maintaining that. So that will be just x the power 3. So this and this will go, right? So that will be 3x squared ln x, then plus 1, not to do 1, so that one will go as x, then will remain with 2 there. So that's how to differentiate that one. I'm sure you can see that it was very simple. Okay, so now what I'm going to do is I'm going to differentiate. This is just a polynomial. So this is a chain, all right? We use chain rule because it is in the form of where chain rule can suit. So allow me to make this one as x, then minus 3x, then plus 5, open bracket to the power 6, like that. So what we do here is you differentiate to say y prime is equal to, so what you do is this power here, all right, you multiply there what is there. So this power will come and multiply this one. Okay, so what do you do for power rule? Suppose you have a function, a function with u inside there to the power something. So you differentiate this function as you multiply 6, okay, then you maintain u, okay, to the power it has been reduced to 5, then times the same u dy, like that. Then what is inside again multiply, so that you multiply. So for this case now, all right, so say y prime is equal to, you differentiate this one, okay, that will be now 6, this 6 there, open bracket, okay. I maintain now what is inside to the power 3, then minus 3 to the power x, I mean minus x, this is 5, then open bracket, that will be now 5, right? So 5, like that. So it has reduced with the power. Then the same thing, multiply times what is inside, the dy dx of what is inside. So differentiating what is inside is 5. This one, this will be 3, right? 3x to the power 2, then minus 3. 5 is constant. So like this. So now our y is equal to, this 6 will multiply with that because it's direct, there is no power there. So that will be 6, open bracket, 3x squared minus 3, okay, then x to the power 3 minus 3 to the minus x plus x, then plus 5, open bracket 5. Okay, so this you can leave at this point, or we can distribute there inside. So y is equals to, this is now 18x squared minus 18. Okay, then x to the power 3 minus 3x plus 5. Then this is what you are supposed to do to differentiate that one. So now we differentiate also the other one. Now this other one, it was very simple as well. Now what we need to do is just to do what? Is to rearrange. We can't differentiate in a situation whereby the variable that we are interested, which is x most of time, it is as a denominator, or it is having a negative power. Or negative power is nice, but having being it as a denominator will challenge us. So I'll pick this one, the d. So I'll say y is equal to, okay, so that will be 5x then to the power 5, then plus, I just want to rearrange this equation. So that will be, this one is already okay, so that will be 2 over 3 x to the power 3. All right, then here it is minus x to the power 2, then plus 1, then plus this one. Now it will be, so we have this form here. So this is where it was trick. Now this is where it was trick. So if I have this form now, what do I do then? So I'm going to take this one towards positive. So I'll say this can be written as 1 over, okay, x to the power half, this root. So meaning that if it goes there, it will be x to the power negative half. Okay. So now we can now differentiate properly. So differentiate this time, that will be what? 25 x, then it will reduce by the power, that will be 4, then plus this 3 times that, the 3 will multiply times 2, it will be 6, 6 divided by 3, that will be still 2. Okay, then x will be reduced by 1, meaning that this time that it will be 2x. Okay, then the x will reduce like that, then this is constant, which is 0, then this negative, it will be there, it will be minus half. All right, then we have negative 1 minus 1, like that. So this will be 2, then that will be negative 1, then that will be negative 2, which is negative 3 over 2. So here we'll have x as to the power negative 3 over 2. Okay, so now we'll just reverse in the good form. So we'll say 25 x to the power 4 plus 2x squared minus 2x, then this one, the way it is there, minus over 2. All right, then the x now will come as to the power 3 over 2. You can leave it like this, or you can put the root, the root symbol. So me, I'll leave it like this. There is no harm. Okay, if you want, you can introduce the root and to the power 3. It will still be the same. Okay, you can put that x, you can write it also as 2. All right, then x the power, just x, then to the power 3, like that. It's still the same at this point. Me, I'll leave it like that. So now coming to this one, okay, so what I'm going to do here is, coming to this one, we know to say y is equal to, okay, exponential, which is e to the power x there, then sec x. So how do we differentiate this one? This is a product rule again. So what we do is, we say we differentiate there. Let's say this is our u, then this is our v. So we differentiate this u, that will be u prime, then you maintain v again, plus you differentiate the same v, you maintain u. So that's what we'll be doing. So now I'll differentiate this e to the power e, you do this, e to the power e, you differentiate this one, then multiply times this function. So dy dx of x of the power is 1. So you just remain with the same x. Then maintain u. So u is now sec x. Then plus, now differentiating sec x, it will give us sec x tan x. Then differentiating times z, the u is now e to the power x. So that will be just e to the power x sec x, then plus e to the power x sec x tan x. So we can factor out to say e to the power x is equal to sec. In fact, even sec is also common. So what I'm going to do is I'll say this is now e to the power sec x, open bracket, we have 1 plus then tan x. So if it was a square, this tan was square, then would have given something else. That was going to be sec again, sec squared. Anyway, we end here. Okay. So that's how we were supposed to write that question. So we go to this one. Okay. So we'll be very fast. Like, see, we just want to solve it in less than an hour. So we still have a lot to do and equations. Okay, so what I'm going to do here is I'm differentiating this one. Okay, again this one. So what you need to know about let me first write this sin 2x plus tan root x, like that. So what we are going to do is, whenever, let me give you a hint, whenever you're differentiating a trig function, let's say cos x, okay, cos x. So what you do is, since you are differentiating any trig function, a trig function always have an angle. So suppose you are differentiating sine x. So this will be differentiated as, you differentiate first the angle, then you differentiate the whole function. So dy dx of this angle we have is x, which is 1. All right, then differentiate now this function, trig function, which will give us cos, okay, x. So that's how it comes up, it is coming about. So that's what we'll be doing there. You differentiate the angle, then you differentiate the trig. That's what we'll be doing. So now differentiating this, we'll say y is equals to, that is y prime, which is just dy dx. Then differentiating the trig function, which is the angle here, it will be just 2. Then I will differentiate sine, it will give us cos 2x. Okay. Then plus differentiating this thing here. All right. How do you differentiate? So we have root x, which is just x to the power 1 over 2. So differentiating 1 over 2, it will be, these 2 will come here, right? So that will be 1 over 2, all right? Then there on top, we subtracted, it will give us half minus 1, that will be just negative half, right? So that is negative half. And negative half, so we have differentiating this function, that it is giving us 1 over 2, all right, x to the power negative 1 over 2 times, now we are differentiating the tan. Tan is being differentiated as sec x. So we have sec, the same thing there, all right, in the root like that. So now what we do is y prime is equal to 2 cos x, like that. We maintain the angle. Then this one, it will be 1 over, plus by the way, 2. Since now it's negative, so that I'll just put as root inside there. Okay, x like that. Then on top there, that will be sec root x like that. So this is how you are supposed to differentiate this guy. So know that when you are differentiating a trig function, always start with the angle. Okay, so let's do the last question. So find the equation of the tangent line to the curve. So when you have tangent to the curve or curve to the tangent, the gradient should be parallel, all right, not perpendicular. But whenever normal is involved, normal to curve or normal to tangent, just know that the gradient will be parallel, will be perpendicular. So now for this case, the gradient will be same as in the next equation, of which they are saying find the equation of the tangent to the curve line. Okay, so meaning that the gradient will not be changed or will not be cancelled the way the way it was supposed to be. So now what you're going to do, find the equation. So what we do for us to find the equation of a n polynomial like this, so what we do, we differentiate, then we'll be able, we get the first derivative, then we'll substitute the value of x, then we'll be able to find the gradient. Then from there we use the straight line equation to find everything needed. Okay, so how do we do that? So we have this function as for x, we differentiate this implicit. By this I mean we differentiate also y squared minus 2 5 x squared y plus 4y the power 4 is equals to 0. How do you differentiate this one? Okay, so you differentiate throughout by so dy dx. I like using prime. Okay, so I'll be using just the prime instead of that dy dx you're able to see. So what I'm going to do is I'll say divide by y prime everything. Okay, so what I'm going to do here, I'll say y prime of this, so okay, dy dx of this, that will be just 16x to the power 3. Then here is a product. There are two things involved. So long as x and y they are involved, then it's a product. So you differentiate the two. Okay, so I'll differentiate here. I'll differentiate this one. Okay, by the way, 8 is constant. So I'll differentiate. I'll have now, let me write this, x squared y squared. Okay, then minus. So at this point I haven't done anything. So let me differentiate this one. So we have x squared y squared. So how do you differentiate this? You differentiate the other one, then you maintain. So I'll differentiate that will be 2x, then you maintain y squared. Then plus, now I'll differentiate, I'll maintain x squared, then I'll differentiate y squared, of which y squared it will be 2y, but we attach y prime there, or the dy dx. Whenever you differentiate y, you attach dy dx, because that is the function. Okay, so that's what I'll be doing there. So here, okay, so I've removed that, pretending that I've removed the 8, I've factored. So I'll maintain x, okay, squared, then I'll differentiate y. So differentiating y, that will give us, that is 2 to the power 2, right? So that will be 2y, okay? It has reduced by 1, but you attach y prime or dy dx, okay? Then plus, here now, this is product by the way. So here now I'm maintaining y squared, then differentiating 2, that will be just 2x, okay, then the power 1 like that, then minus, this time that this again is a product rule. Okay, so allow me to say I've worked out here, so that will be 16x to the power 3 plus 8 times that will be 2 times that, 2 times that will be 16, So let me light it properly, this thing. So I have 16 there, x to the power 3, then plus, this time that is 16, okay, and x squared, y, then y prime. Okay, very important, this prime. Then plus, here we have just y squared. No, it's not y squared. I have a coefficient there, which is 2xy squared or 2y squared. So I'll say this is 2y squared x. Hope that is clear. So what I'm going to do here is, I'll say I've managed to arrange this one, right? I've managed to arrange. No, I'm supposed to multiply with 2, with 8. This 8, I'm supposed to multiply throughout by everything. So that will be just 16. Okay, there it will be 16 because 8 to multiply. So that will be 16, right? Then I'm done there. So now I'm done at the going this side. Now it's just the, so this is also another product rule. So I'll say minus. So the 25, I'll maintain it there. Okay. So meaning that I'll have here, I'll differentiate, I'll maintain x and differentiate y. So I'm maintaining x squared, the differentiating y will be what? Will be just y, you differentiate y to be just 1, then you attach y squared always, I mean y prime, like that. Okay, then plus, okay, plus, now you differentiate this x, now that will be 2x, then you maintain y like that. So I've remained only this part. So now this is now 16 x to the power 3, again plus 16 x squared y prime, then plus 16 y squared x, then that will be what? You multiply throughout, that will be minus 25 x squared y prime, then plus again 25, now that will be 50. Okay, 50x 50x, then now differentiating this one and left this one, that will be now plus 16, that will be plus 16. It is y, so you attach always dy whenever you are differentiating that. So it will be 16. Okay, is plus, but it is supposed to be a negative. Okay, no, I've already done for a negative. In fact, here it is supposed to be a negative because this negative times that is negative, so it's negative there. So that will be negative. So that times that will be now 16 y to the power 4, 3 now, then y prime. Okay, so now we have 16 x to the power 3 plus 16x to the power 2 y prime, then plus 6, no, 16 by the way, 16 y squared x minus 2 5 x cubed y prime. Okay, then minus 50 x y plus, all right, then plus 16 y to the power 3, then y prime there. So we are going to arrange now the one with prime alone. So this will be, here I have 16 x squared y prime. Then I have also here minus 25 x to the power 3. Then y prime. Again I have here plus 16 y to the power 3. Then y prime. So now these are the prime that I have. So meaning that I'll equate this one to the other side. It was 0, by the way. So these ones without prime, I'll divide them. So here I have 16 x to the power 3, which is there. Okay. Then I have here, where else do I have? Here I don't have y prime here. So I'll write again plus 16 y squared x. Then here again, it's here where I don't have the prime. So that will be minus 50 xy. Okay, so now what I'm going to do, I'll differentiate, I'll factor out what is common. So I'll say y, open bracket. In short, I'm dividing everything that will remain. So that will be now 16. Let me just do this. It's direct instead of me wasting my time. What I'm going to do here, I'll say y will be my subject to the formula, meaning that I'll divide everything here, removing y, into this. So this will be 16 x to the power 3 plus 16 y squared x minus 50 xy. Okay, then divide by this thing, everything we have here. So we have 16 x squared y. Then this one I've already factored out. Then minus 25 x cubed. Alright. Then plus 16 y to the power what? 3. Then the prime is already there. So now it's just a matter of substituting to find the gradient. So now find the gradient. We are substituting everything now. Okay. In this expression, we are substituting everything in the expression. Okay, substituting everything now, that will give us, so say now our m. Okay, so substituting, we have 16 there. Okay, let me just get a calculator. I now need a calculator there. That's why it's allowed to use a calculator in this course. So 16 there, open bracket. Our x they are saying is 2, which will be just 8, right? If to the power 3, then plus 16 again, open bracket. Our y is 1, that will be just 1, right? Then open bracket, there is 2 there, all right? Then minus 50, open bracket. Our x is 2, open bracket, there is 1 for y there. Okay, so now again we have 16, open bracket. We have 2x, that will be now 4. Okay, then open bracket, y is 1, right? Minus 25, open bracket. So our x now is 2, that will be again 8. Okay, then plus 16. Okay, open bracket. Our y is 1, which is just 1. So our m now is equal to, okay, let me just punch on the calculator. So I have 16 times, so 16 times 8 plus, that would be just 32, then plus, not plus but minus 100 just. Okay, so that would be 60 on top, then over, we have 16 times 4, okay, then plus 16, okay, then minus 25 times 8. So negative 120. I don't know why it's giving me negative 120. So that will be negative 120. So we can see that 6 into this, 6 into that, that will be negative 1 over 2 as our gradient. So from there, then what we are going to do here is, what we are going to do there is, we know to say y is given by mx plus c. So I like using this one to say y minus y1 is equals to mx, okay, x minus x1. Okay, so that's what I'll use. So why I know y1 is the what? Is 1. Then it's because my gradient is now negative 1 over 2 because it is tangent and the curve. Then open bracket, I have x there. My value of x there is what? Minus 2. Okay, this and that. So that will be y is equal to, okay, before that. So let us hold on a bit there. We hold on a bit. So now we are saying we distribute there that side. That will be y minus 1 is equal to, that will be negative 1 over 2x. That will be x. Then that will be plus just 1 because 2 and 2 will cancel, right? So then this and this, that will give us 2. So it will be y is equals to negative 1 over 2x, then plus 2. Okay. So plus 2. So this is the equation which was needed. So that's the equation they wanted. Okay. So now we are going to show this second derivative, the derivation of sec tan and x as indicated. All right. So now what you're going to do here is, I'll bring the same equation and differentiate. Hope this was clear what I'm labbing. Hope it was clear. Okay. Okay. Okay, so what I'm going to do is, I'll get this one. If y is equal to this, okay, y is equal to, open bracket, sec x, all right, then x plus tan x, okay, then is equal to, so we need to show that the dy dx is equal to, in short, we are just there to find the dy dx of this. So the dy dx of this is a product type, right? So I'll differentiate this one. I'll say this is sec squared x, all right, differentiated, then I'll maintain the same x, all right, I'll maintain the same x plus tan x. I've maintained that one. Then again, the next thing, then what I'm going to do is, I'll maintain sec x and differentiate this, what is inside there, all right. So differentiating, that is x, differentiating x, that will give us what? So differentiating x, what is inside there, it will give us what? It will give us x, that will be just 1, right? Then differentiating tan, that will be sec squared x. All right, so meaning that if I'm to distribute this, I'm going to have sec squared x. All right, again there's x there, so this x need to be here. Okay, then I have sec x again times tan x. So this will be tan x, then sec x squared. Alright, so I've multiplied this one and this one. It is this and this and that is that. So I have again sec x, then plus sec x, then sec squared x, like that. So this is, let me say, y prime is equal to, we have x sec squared x plus tan x, alright, then sec squared x, okay, then plus sec x plus sec x sec squared x. So now this is what we are going to do is, we say y is equal to, we need to do something such that we need to reduce this equation. I can see one thing here, all right. Okay, so what we need to do is, okay, so there's something that you need to add up. Okay, so what I'm going to do here, I'm going to factorize sec here, all right. So I'll remain with the x. Okay, let me do this. So I'm going to factorize this x there. So I have x sec x squared, then I'm bringing the same plus sec x sec x squared there, all right. Then from there I've done this one and this one, so I've only remained with this one and this one. So here I'll have plus, okay, in fact I can say sec squared x, then tan x plus this sec x here. Okay, so now it is like, what can I do here? What is common here? I have sec x. All right, so sec x is common there, right? Let me do sec x tan x, sec x tan x, sec x tan x. So I have x. In short, I have sec x as being common, then that would be sec squared x, then plus sec squared x, like that. Okay, so that is for these two. All right, then what I'm going to do here is, for here, okay, I have plus sec squared x, then tan x plus sec x. Then now what I'm going to do here, I can add up to this, so this can be, all right, remember there's x there, so I'll say x sec x, open bracket, then 2 sec squared x, okay, then plus sec squared x, then tan x plus sec x. Okay, so now from here, what can we do? We are trying to trace this pattern. Okay, we have 2 there and we have tan there. So what I'm going to do here is, this can multiply, right? So that will be x sec x, all right. Then allow me just to write even the same 2 here again, all right. So allow me to write it as Okay, before that, I've seen something. I need to test one thing. Okay, I need to test something here. Okay, so I need to test something here. So I can put these two here, all right? But again, sec x is same as 1 plus tan squared x. Okay, again, that's another problem. So here, then I have, again here, I need to do something. Allow me to do this. This was a big question. Okay, so what I'm going to do here is, I'll say, I'm trying to trace this one. I need to make sure that I have sec x squared like that. So my goal, I should just be at least manipulating what is inside there. Okay, all right, so we say, what is sec x? All right, so we know that at this point, okay, let me just do at this point. In fact, it was supposed to be tan. Why is it sec x plus sec x? What was I writing? So let me start from there. Okay, so we don't have this identity. We don't have this sec x plus sec x. Where is this coming from? Okay, from here, sec x and sec x. So they don't have. So what I'm going to do here, instead, I'll have y is equal to x sec x open bracket. So sec x squared is same as 1 plus tan squared x. So I'll say 1 plus tan squared x, that is sec. Again, another 1 plus tan squared x. Okay, so that's the meaning there. So meaning that I have, again here I can have, okay, I'll leave it like this here. I'll leave it like this. So, all right. So the goal is this one. So here I want to disturb here the way it is the pattern. So what we need to do is now, I'll say sec squared x, then tan x plus sec x. Okay, so now I'll say y prime 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 is equal to x sec x. Then we have this and that, that is 2, then plus that, that will be 2, okay, plus 2 tan squared x. Okay, then from there, what are we going to do then? What are we going to do from there? So what have we remained with? We have managed to achieve this. We have managed to achieve this. The only thing we have remained is, where is x tan x? Okay, so let me do something here. Okay, so here, what I'm going to do is, I'll say here, I know this is sec x, this is tan x. Why am I having, okay, this is plus sec x. So what I'm going to do here is, I'll say sec x squared is same as 1 plus tan x squared plus, okay, so then I'm putting that, then here I have tan x. Okay, so tan x there, All right. Then plus sec squared x. So I'm running out of space. I don't know if I can go to another page, but that will consume my time because I'll be moving like that. Okay. Where should I be? What should I do now? What have I pressed? No, 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 no. Where should I press? Okay. Let me just make it in the next page. So let us just do on the next page. It will be a very long video. Okay, let me just do on the next page. I'll make another video. See you in chapter 2.